Hello everyone. So today we're going to be looking at a calculus question. We've got f of x equals x squared ln x, and we're going to find inflection points, if any, and intervals where f of x is concave up and concave down. Okay, so just to recall what an inflection point means, an inflection point x naught is a point for which f of x is continuous and the concavity changes at that point x naught. If your second derivative is greater than 0, f of x is concave up, and if your second derivative is less than 0, then f of x is concave down. So basically what I mean, going back to that first bit of an inflection point, is your graph could be, let's say, concave up, and here then it goes to concave down, that's where x naught would be, or likewise it's concave down and then concave up at x naught, okay? So those are the things that we're looking at for when we mean an inflection point. Now, in order for us to start with that, we're going to find a second derivative. This is really important. When you're working with a function, you have to figure out what your function is, what the domain of the function is, okay? Very important. In this case, the domain would be 0, not included, to infinity. Yeah, x squared takes anything, but ln of x only takes things that are greater than 0, okay? So that is what your domain would be. Now, for our derivatives now, yeah, we're going to take that into consideration because we're going to build the number line eventually. So let's take a derivative, first of all, and I have to use a product rule. So I'm going to start by holding x squared first, then taking the derivative of ln of x, which is 1 over x, plus then I will hold ln of x and take the derivative of x squared, which is 2x. And simplifying that would give me x plus 2x ln of x. And I'm going to go ahead and take the second derivative now. So the derivative of x is 1, and I have to do another product rule with 2x ln of x. And I'll do the same thing. I'll hold 2x, take the derivative of ln of x, which is 1 over x, plus now I will hold ln of x and take the derivative of 2x, which is 2. And after simplifying, you get 3 plus 2 ln of x, because those x's cancel. So when we're looking for inflection points, those inflection points, where do they occur? Well, is that it's where the concavity changes. So we look at places where the second derivative is equal to 0, or where the second derivative is undefined, but f of x is continuous, okay? So let's try to find them in the first category. So where's my second derivative equal to 0? 3 plus 2 ln of x equals 0. ln of x equals negative 2/3. Oh, I'm sorry, negative 3/2. My apologies. So x equals e to the negative 3/2. Okay. So e to the negative 3/2, if you plug that into your calculator, is less than 1 but bigger than 0. Okay. So that's one of our points. And the next category is if your function is second derivative is undefined but continuous. Well, if you look at your second derivative, it's undefined pretty much anywhere less than 0 because it's 3 plus 2 ln of x. But see, that's your function is not continuous at those points. It's continuous anywhere in the domain from 0 to infinity. So those points are not, we don't have anything from that category. All right, so now what we're going to do is we're going to do a number line. And on this number line, this is where I, again, take that domain into consideration. Here's 0. Then you have e to the negative 3/2 on there. And this number line is, I want to know what the sign of the second derivative is. Now, if we try to figure out what e to the minus 3/2 is equal to, you would get second e to the negative 3/2. That's around 0.22, okay? So let's make a note on that. So then I'm going to do this. I'm going to take 2 points, one to the left and right of e to the negative 3/2, so which would be 1
and maybe a fifth. Okay, 1/5 is 0.2. And what we're going to do is we're going to plug them into our derivative and see what we get. So if we plug in second derivative of 1/5, this would be 3 plus 2 ln of 1/5. Okay, and if we did the math, let's see, i.e. using our calculator here, 3 plus 2 ln 1/5, you get a negative. And that's all I care about. I care about the sign. Okay, so this is less than 0. And if I take the second derivative at 1, this would be 3 plus 2 times the ln of 1, which is 3, which is positive. So it's going to be, positive value. And let me just write negatives here. Pluses on the other side. And then from there, we can figure everything out that we're looking for. So for part A, do we have an inflection point? Yes, you do. It's at e to the minus 3/2 because your function goes from concave down to concave up. And where's your function concave up? Well, it's concave up on e to the minus 3/2 to infinity. And it's concave down on 0 to e to the minus 3/2. Okay. And there we go. So that's the procedure that you do pretty much for every function. And just as I said before, please don't forget to find the domain of the original function. All right, and thank you so much for your time, and I hope this helps.